Socks? Fishing socks. Pretty cool, right? See, there's a fish.
Why is this yield price so high up? Are you wearing those things that look good?
Yeah, I got the thing, because I have a brokenheel.com.
Oh, yeah.
Remember? So I have that little thing on there. It's like a cushion. All right. So last week we were solving quadratics and we were then simplifying radicals because some of our answers to those quadratics had a square root sign in it. Remember? Readings? Yeah. Okay. So what's the quadratic equation that we are going to be solving and how is it related to geometry? What did I say last week? Side? It does start with a P. Okay, Pythagorean theorem. Okay, so we're going to look at the Pythagorean theorem today. We're going to do some work with finding sides in a right triangle. Pythagorean theorem. I think we even wrote it down in class. This is the formula we use, and then we talked about what those mean. Did we do this? Yes or no? Am I imagining things? Okay, so we talked about it briefly, but then we just started getting into solving quadratics. And now we will actually solve this quadratic equation. All right. So what happens is we've got our right triangle. We've got three sides in a right triangle. What are the sides that make up the right angle called? Talk about this in unit 3, triangle unit. What, Jasmine? The what? The what? That's what I'm saying. Sides that make up the right angle. What? Legs. Those are the legs. So in this formula, A and B are the legs. The order doesn't matter. Okay, A and B are the two legs. What's the side opposite the right angle, Kelsey? What? The octopus? What? Yeah, I bought it. You started to say that, kind of. No, sounded like octopus through your mask. Yeah, okay. And then C is the hypotenuse. So this is a leg. This is a leg. C is the hypotenuse.
What's how you spell it?
I think that's how you spell it.
I thought there was like
Am I wrong? Now you got me thinking. Hypotenuse. You think it's Noose?
not
Like
oh,
moose?
No, like
What's the plural of hypotenuse? I did spell it right. Yeah, right. What's the plural? Like, because hypotenuse, like, is it like moose? Like, what's the plural of moose? Moose. What's the plural of goose? Geese. So what? Hypotenuse? I know I'm being funny. No, okay. It's not hypoteni. No. When do you do fungi, fungus? What's up, Sophia? You guys looked it up for me? See, I am also an English teacher on the side, so I know how to spell stuff. No. All right, so what you do, or what this does, is if it is a right triangle, this is always going to happen. You take the leg and square it. You take the other leg and square it. You add those together and you get the third side. So an example would be if I had a triangle and I said this side was 3, this side was 4, and this side was 5. This is a right triangle. And what happens is if I take this leg and square it, 3 squared, then I take this leg and square it, 4 squared, add them together, we're going to get 5 squared, right? We've kind of already like done problems with this in the last unit. Remember when we were like, find the side. We're like, how do you find it? Do you remember the Pythagorean theorem? We did some work with this. All right. So we've got 6. Oh, do I know how to do squared? 3 squared is 9 plus 16 equals 25. See what happens? 25 equals 25. Alice, what's up? Huh? Tape? What did you tape for your notebook, your invisible notebook that you have out right now? You want to tape some of the pages together? Okay. Now, all right. Now, what we can do with the Pythagorean theorem is this, which we can check to see if something is a right triangle. And we'll talk about when you actually do that. But what we're going to do today is we're actually going to use it to find the missing side in a right triangle. So if this is my right triangle, and I know that this side is 5, and this side is 12, we can use the Pythagorean theorem to find x. We can use it to find the missing side. So the legs are 5 and 12. Substitute them in for a and b. 5 squared plus 12 squared equals x squared. X is the hypotenuse. You plug that in for c. Okay? Question so far? The order that you plug them in doesn't matter. A and b don't matter. C is the one that matters. All right? So 5 squared is 25. 12 squared is 144 equals x squared. Okay, add those together. 169 equals x squared. And then how do we get x squared by itself, man? We'll do that next. Okay. Bill again? Yeah. All right. Take something squared by itself. Take the square root of both sides. X equals. Now, the square root of 169 could be 13. It could also be negative 13. But in this problem in geometry, like when we were solving quadratics last week, we'd have 2 answers. Well, how come now we only have 1 answer? Why is it only 13? Alex?
Because the side length can't be negative.
Right, can't have a negative side length. Okay, so we've got the 1 answer. All right. Well, also when we were simplifying the square roots, right? Last week we'd only do the positive square root. We weren't doing the negative as well. Right. So it's the principal square root is what we're looking at. Side. In this example, no. Of course, we're going to get there right now. Josh. Okay, yeah. Okay, you guys are all saying the same thing, right? Good job thinking ahead, right? That's where we're going next. You guys want to be the teachers? You guys know where we're going next. Mia? Anyone? You want to make up a problem? You guys think you can do it? Can you make up a problem that's going to have an integer answer? Like, look at me. I made that up, 13. It wasn't a decimal. Why am I so good? What's up? I guess. Josh? Well, I gave you the side lengths that work where the sum of any 2 sides has to be greater than the third. Is that what you're talking about? But not integer values and not to work in this, right? Like I can make up one right now and I know your answer is going to be an integer. Watch this. Here's my triangle. You ready? 24, 7, x. Now, what numbers, variables are going where? Where's the x going now? Kelsey? It'd be for B or A. Again, the order doesn't matter. Now the hypotenuse is C. So this is exactly what you guys were just talking about. 24 gets plugged in for C. These are going to get plugged in for A and B. Okay, so we're going to get x squared plus 7 squared equals 24 squared. Now we solved quadratics like this last week. We just undo the order of operations. X squared plus 49 equals 576. Okay. Subtract 49 from both sides, x squared. Oh, you know what? I didn't make it so it's an integer. I lied. I'll show you how I lied in a minute. Darn it. My brain flipped the two. You'll see what I mean in a second. All right, well, what? Subtract 49 from both sides. What do you get? 527? Is there, can you even take, is there, so x equals the square root of 527.
I got 517. Minus 49, remember?
Minus 50 would be 26.
But no.
Yeah, that's right, 527.
So 16 minus 9. You're right.
Okay, you just like didn't carry a one or something. Does 527 have any perfect square factors? So that's already simplified. That would be your answer. OMG.
Wait, but I mean,
No. An integer is a number that's like on the number line, right? I wanted a rational number also, like 4 is an integer. 7 is an integer. This is an irrational number. The square root of 527 goes on forever. It's far from an integer. Well, right on the square root side. What's up?
Are you also able to correct it, like if you know c squared, could you never do 24 squared minus 7 squared?
Yeah, it's the exact same thing. That's just solving, right? That's the same thing. Okay, now the reason I messed up is because there is, if I did, I'm just gonna do this. We're gonna do the exact same problem because this is the problem I wanted to do. I wanted to make this a 25. Now do the same thing. Now you see, now you'll see why. Wait, what are you talking? How do you know to get an integer? And then we can talk about it. So solve that one for x. Same steps. So right, yeah, Josh, right now in your head, you're doing 25 squared minus 7 squared, right? No? I talked to myself? Okay. Alex, no notes today still, huh? Even after my comment with your invisible notebook? Alex has got an invisible notebook too. Where do you guys get that? What store?
I'm just using my brain.
Staples has invisible notebooks? How about Office Depot? Is that still around? Oh, it is? Oh, because I was gonna make a joke like Office Depot is no longer around, but it is around. It's invisible, and that's where you get the invisible notebooks. And invisible pens. Why are you guys looking at me like I'm wearing? Same steps, x squared plus 7 squared equals, now it's a 25 squared. Now watch what happens. X squared plus 49 equals 625. Subtract 49 from both sides. X squared equals 576. Now take the square root of both sides. X equals, well, look, what's 24 squared? 24. 576. The square root of that is 24. So what I was trying to do is that the last time, because I can make up problems where I know the answers are going to be an integer in my head. Do you think I'm doing all that math in my head? Hi, what's up? What does that mean?
Like, he's asking why you did it twice.
It's just two separate problems.
But it's 25.
Now it's 25. This is a new problem. I could change this to anything I want. I could change it to a 30. I could change it to a 20. I'm making up the problem. I'm the teacher. I'm allowed to. What? You want me to make up another one? Find x. What would be a matrix God? Mine's full. Time to the same. All right. So substitute it in, 16 squared. Well, where's the 34 going? Yeah, 34 is the hypotenuse. That one has to go in for C. The 16 and the X don't matter. Those are the legs. The legs, the order doesn't matter. 16 squared plus X squared equals 34 squared. 16 squared is 256. X squared, and then what's 34 squared? 1,156. Okay, and then subtract 256 from both sides. What do you get? What do you get? And then the square root of 900. Was it 1156? 34 squared is 1156? Oh yeah, that makes sense. Because we need the 900 because now the square root of 900 is 30. Oh, look at that. Mr. Sokolowski was able to get an integer again. Are all the answers integers? How am I doing that? As I've memorized every single triangle in the world. That's how I'm doing it. Now I'll make up one that is not an integer answer. Ready? Now I know the answer is not an integer, but I do know the answer has a square root of 3 in it. Am I right? Oh, you're not done yet? Square root of 3? You got my square root of 3? You guys remember how to simplify radicals from last week? Where's your square root of 3? Am I right? Dominic?
Not the square root of 3.
What? Let's see. We got 10 squared. Right? Plus X squared equals 20 squared.
Sure.
Okay. 10 squared, 100. Plus X squared, 20 squared, 400. Subtract 100 from both sides. X squared equals 300. So X equals the square root of 300. This is why we simplified radicals. Can we leave our answer like that? It's not simplified. So we need to break this down. What's a perfect square factor that goes into 300? 100. This is the square root of 100 times the square root of 3. Told you. 10 rad 3 is the missing side. Told you it had a rad 3 in it. Told you I memorized every right triangle ever. Okay, now, yes.
So like, let's say like this was like more complicated, but like it's not though. But like, could we do in like the very first equation where it's 10 squared plus x squared equals 20 squared? Could we do like minus 10 squared on both sides to just make it x squared equals 10 squared?
No, that's the wrong order of operations. 10 squared is 100. Is the answer 100?
No.
Okay, that's not the correct order of operations. You square something before you add or subtract it. You're subtracting it before you squared it.
Oh,
Make sense?
okay.
PEMDAS style
Yeah.
order of operations. Okay. All right. Now, remember last unit? What was last unit on? What? Similarity. That's how I'm doing these problems. Similar triangles. What's true about similar triangles? What was true about the sides in similar triangles? Josh? The scale factor is the same, right? Okay, so the way I'm doing this, well, here, let me just leave this one up there, right? This was an 8, no, what was this? This was a 16, right? This was a, what did I have here? That was a 34, I should remember that, okay? So 16, 34, and then I knew this was 30. The reason I knew that I was gonna get an integer is because I know that 8, 15, 17 are the sides of a right triangle. How do I know that? Because it's called a Pythagorean triple. A Pythagorean triple are integers that always work in the Pythagorean theorem. And I know that 8 squared and 15 squared added together is going to give me 17 squared. 8 squared is 64. 15 squared is 225. And 17 squared is 289. 289, 289. That's always going to be the case in a right triangle. Well, similar triangles are going to have the same thing. The Pythagorean theorem will still work. This triangle is similar to this triangle. 8 times 2 is 16. 17 times 2 is 34. That's how I made up the problem in my head. 15 times 2 is 30. So if you take all those sides and multiply them by 2, we've got a right triangle. A similar triangle to that one. So what I could do is I can make up another problem over here. I'll draw a triangle, and I could say that this side is 32. This side is 60. Now, instead of doing the Pythagorean theorem, we can use what we learned last unit, and now we should be able to find this side. Now, you could do the Pythagorean theorem. 32 squared plus 60 squared equals c squared. Break out your calculator, punch all the stuff in, punch it in here, and get your answer. Or we can figure out the scale factor. How do you get from 8 to 32? Times 4. How do you get from 15 to 60? Very good. People are holding up a 4. I think that means times 4. People are scared to talk. Okay, times 4. Well, how are we going to get from 17 to the new hypotenuse? Holding up the 4s again. That's the scale factor. 1 to 4. So multiply 17 by 4. What do you get?
68.
Boom. Now, if you did the Pythagorean theorem, you would get the same thing. It's easier to do it this way, though, right? I mean, this is quicker. It's quicker than doing 32 squared plus 60 squared equals c squared, 32 squared. I don't even have a calculator, Mr. Sokolowski. How am I supposed to do it? We'll do it that way. What's up, Josh? No. 8, 15, 17. Eight, 15, 17 is one of them. Remember the first example I put up there? The first example I put up there was 3, 4, 5. 3, 4, 5 is one of them. 3 squared plus 4 squared equals 5 squared. 6, 8, 10 is 3, 4, 5. It's part of that family. It's a similar triangle to that one. What's up? Question? You have your hand up, yeah.
So is there a way to like know what 3 numbers will be a Pythagorean theorem?
Yes, I'm going to tell you them right now. I'm going to give you all the families. Well, not all of them. I'm going to give you 5 of them. 4 of them are ones we use all the time. So 8, 15, 17, 3, 4, 5, 5, 12, 13. And then this one, the one that I messed up the first time, was 7, 24, 25. Those are families of Pythagorean triples that we use often. Now, there is another one that's sometimes used, 9, 40, 41. So we could start using those today when we do some of these problems. All right. And what I did over here, we're going to get to later this week. This is called a special right triangle, which also has some ratios that we'll talk about. And that's how I knew I was going to get a square root of 3. Okay. I also know sometimes when we'll get a square root of 2 based on these similar triangles. We're not going to get into that yet. All right. So right now we've got the Pythagorean theorem and Pythagorean triples. So an example of being able to use the Pythagorean triple or the Pythagorean theorem. There's a rectangle. Okay. This side is 10. This side is 24. I want to know the length of the diagonal, D. Find the length of D. That's what find D means. We've got a rectangle. So all the sides are right angles. So if we have a triangle that has a right angle in it, what can we use to find the missing side?
Pythagorean theorem.
Very good. What this unit is on. Okay? So we can use the Pythagorean theorem. Figure? What's his name? I don't know. Now, who's doing the Pythagorean theorem right now? So you're going 10 squared, right? 10 squared plus 24 squared equals c squared. That's how you plug it in. Who's not doing the Pythagorean theorem? Who's using last unit? Anybody remembering last unit or what we just talked about 3 minutes ago, Sai? Go ahead. Just joking. It was just joking. It was just like it was a big build up to the answer to my question, and then yeah, okay, all right, go ahead.
Are there, how do we know that
This is the hypotenuse. That's what we're missing. The hypotenuse is always here, c squared. So in this case, the c squared is a d squared. Okay, the hypotenuse goes there. The other ones don't matter. Eamon, you have a hand up? No? Okay, what is it? 26. Did you do this?
I did it in the beginning, but
You realize something over there. All right, so hold on. So we still get 10 squared. Whoops, sorry, let's actually do it. 100, 476. No, 576. What? 576 equals d squared. What is this? 676 equals d squared. Square root of 676 is what? 26. So the diagonal is 26. Now, we could have used similar triangles. This is a family. Which family does it belong to? How do you realize that? Okay, you started to see the scale factor. 5 times 2 is 10. 12 times 2 is 24. So then you could just do 13 times 2 is 26. So it's a faster way to find that answer. Now, why would you want a faster way to find an answer? Josh? Okay, the life still find an easier way to do it. When would you want to do something quickly? So you can move on to the next problem. How many people finished the test last unit? Okay, right. So you want to be able to do things more quickly, like the SAT is a time test. So like if you can know these, you can get this problem done quicker and spend more time on a more difficult problem. Ramesa, what's up?
do the triples have to be in the exact order, or can they be?
This is always the hypotenuse, and then those don't matter again. Okay, so like I ever give you a hypotenuse, like if I give you a problem like this, and you're trying to determine if it's a triple or not, it's easy if I give you the hypotenuse. Like I could say like, this is 25, okay, and this is 20. Well, is it this one? 25, and then no, it's not that one. Oh, that hypotenuse, hold on, 5. Is 5 going to 25? 5 times 5 is 25. 4 times 5 is 20. So then this is going to be 3 times 5, 15. Okay, Josh, what's up?
Like, is there a thing that they all have in common with Pythagorean triplets, or is it just like people kind of?
They just work in the Pythagorean theorem. Those are integers that always work in the Pythagorean.
Is there a reason for that, or do people just kind of try and throw numbers together and realize certain variables?
Probably. Yeah. Chelsea? Right now, that's what you have to, for the Pythagorean theorem, you need 2 sides. Now later on, when we get the trig, I'll show you where all you need is an angle and a side, and you can find the other 2 sides. Okay, but right now we're doing the Pythagorean theorem. So we're going to practice more tomorrow with the Pythagorean triples. Okay, we're going to do a few problems right now for practice. So let's look in I did post partial Pythagorean theorem packet in Canvas. So let's look at that. Let's open that up.